Hello, my name's Clinton, and I'll be your guide through this first module of Day 10. We're going to talk about the sine function. Please don't forget to pause this presentation at any time if you need more time to think about something. We're going to talk in the next 3 modules about 2 new functions, or more precisely, families of functions, called sine and cosine. These 2 functions are programmed into your calculator, and you can compute values of the functions by using the sine and cos keys. It's important that you have your calculator in radians mode before continuing, as otherwise your answers will be all different from the answers in this presentation. Make sure your calculator is in radians mode, and then check that you can get the following values for the 2 functions, sine and cos. Press pause, and then, when you want to continue, press play again. We're going to have a more detailed look at sine first. We abbreviate sine to sin, but notice that this is still pronounced sine. The most important property of the sine function is that it's periodic. This means that the graph repeats itself over and over again. You can check on your calculator that the sine function has the same values at numbers which are 2 pi apart. For example, sine 0, sine 2 pi, sine 4 pi, and sine minus 2 pi are all the same, and are all 0. You won't get the right answer if your calculator is not in radians mode. The graph of sine repeats itself every 2 pi. Here's what the graph looks like. Notice that it's always between y equals 1 and y equals minus 1, and that the graph repeats itself every 2 pi, as we've just seen. Here's a summary of the important properties of the graph. First, minus 1 is less than or equal to sine x, which is less than or equal to 1 for all x. As we noticed before, the graph is always between 1 and minus 1. We say that the function has amplitude 1. Sine of x plus 2 pi is equal to sine x for any x. Again, as we noticed, the graph just repeats itself every 2 pi. So whatever the value of the function is at x, it's going to be the same at x plus 2 pi, and x minus 2 pi, and so on. We say that the function is periodic with period 2 pi. You can also see from the graph that sine of negative x is equal to minus sine x for all x. Here's sine pi on 2, and here is sine negative pi on 2, for example. That is, if we have some point on the positive x-axis, the y value at that point is the negative of the y value at the corresponding point on the negative x-axis. Functions with this property are called odd functions. So sine is an odd function.